So in this video, I'm going to show you how to use my library called jutsu.ai. What it is a wrapper for the Deep Learning 4J library in Clojure. And Deep Learning 4J is a really great deep learning tool for Java ecosystem, and it has a lot of different architectures that you can use. So I made this layer to make it easier to do machine learning, basically with less typing and more lispiness. So this is an example project that we're going to be basing our video off of. So the first thing you want to do is make sure you have Java installed. And you can do that by typing this in your terminal. So I have it installed, but if you get an error on this, you should go ahead and install it, which there are a ton of resources on Google about this. The next thing you want to do is make sure you have the boot Clojure build tool. And what it does is it builds your projects for you and also takes care of your dependencies. So you can install it by following the instructions on their GitHub README. So we're going to be using a project template I created, which also includes a IDE called Nightlight, and it's actually packaged as a library, which is pretty convenient. So we're going to call this jutsu.ai demo. And we can go into this project. And we can see that it's created a project for us. So let's run boot night, which I'll explain how that works in just this second. So we can access the IDE with our browser, and we go to our build.boot file, which basically works as a Clojure file. And you can see that we list our dependencies, so Nightlight is one of them. And if you have tasks that you want to do, so we have a Nightlight task, we can include that as well, or other functions. So I prepackaged this night task, which we use right here to open up the IDE. And we can open up another tab and run boot run, which is another task. And that will run the code in our main function. And see here, run hello world. And so this is where we'll be doing all of our coding. Now, since we're doing machine learning, we need data. So we're actually gonna make a directory called data, and I'm going to just create a new file in data called iris.csv, and I have this link right here where I just followed. You can just look up iris dataset in Google and you can find it. So we'll just copy this into here, and Nightlight does autosave for you, so it should already be saved. Now, Nightlight is pretty basic, so I can't do multi-line editing. So I'll just quickly open up Sublime Text to do this. And we could do this data processing, with Clojure, which is great. But it's just going to be easier to do this with Sublime because it's not that much data. And this data set has different species of flowers, and the label was that name you just saw, but we're feeding this into a neural net, so we need to make it numeric. So we're just going to replace that with 0, replace this one with 1, and then the rest are going to be 2. So we can just use Sublime Text, which is, the command for that is Command-Shift-L. and then so we saved that and good to go. I don't do Sublime Text for Clojure because it doesn't look as good, in my opinion, as Nightlight, but you could do it all in Sublime Text if you wanted to. Nightlight gives you nice features for Lisp, like parentheses, automatic kind of closing, and also gives you rainbow parentheses, which is I love. So that's why I'm using Nightlight. So now we got to reload this, and we see that our data is good to go. The next thing we need to do is add the data directory to our resources so our project knows where to find the data. Cool. So now we have the data ready. Let's add our dependencies. So the other one will be the jutsu.ai, of course, which is good. We should add that because we need it. But we also need our backend matrix library, which is called ND4J, which is what deep learning 4J is built on top of. And we just include that. And I used this one specifically because I'm running it on the CPU. But if you wanted to do GPU, you would just do this, and you can run the same code. So now, we don't need to run any commands to make sure these are installed, because boot will do that for us the next time we run our program. So let's add jutsu.ai to our code, and we just do this, and then we give it this alias. It's called Actually, I'm gonna call this AI. I like to call it AI. Makes more sense. So the first thing we want to do is load up our data. So we're going to define a variable called iris iterator, and we're going to use this, and we're going to use the classification CSV iterator, and we can see an example use of this right here. Now we're going to give the file name. We're going to give the batch size. So if you're using a large data set, it will feed the neural net the data in batches, which is nice as opposed to just doing it one by one. But since this data set is so small, we can just do the whole thing, which is 150. The next value is the index or the column where the label is located. So that's going to be at 4 because there's 5 data points in each row, and we start at 0. So 0, 1, 2, 3, 4. So our label is at the 4. And then we're going to tell it how many classes is to look for. So there's 3 because there's 3 different species. And we can see that this works by calling next. And what this dot here is for is because we're calling a Java method. So this is giving a Java object, and we can call the dot next to see what happens. So boot run. And this should print out the whole data set if I did this right. Yep. Just like that. Cool. Now, the next step is to configure our neural net. And jutsu.ai works by doing the configuration with just Clojure data. And then what jutsu.ai does is it translates the data into a Java configuration, or translates the keywords into Java methods. So you can just use Clojure data, and our configuration will start. We can set the learning rate to, what was good? 0.5, and we can do momentum to be 0.9, and so on. I mean, there's lots of different configuration variables which you can learn about on the Deep Learning 4J website, and then jutsu.ai will have them pretty much automatically because it just does the translation for you. So we have the layers config key, which is special and also very important because that's the body of our neural net. So we're going to define our first layer, our input layer, with this dense keyword, which is the type of layer we're making. And then we can do our number of in, which is going to be 4, because we have 4, it's going to take a vector with 4 numbers in it. And then the out, so this is going to determine how many hidden nodes we want. So we only want 10. And then we're going to do the activation, and we're going to give it another keyword called relu, which jutsu.ai will figure out that this keyword mentions the relu loss function, or activation function. We'll get to loss function. So now we just make our next layer, which is also dense, and then the number of in is the number of out from the last one, and the out will be the same, and we'll just do the same thing for here. Now we're going to do the output layer, which is kind of special because it has an extra argument that we're going to put, which is the loss function, and that will be negative log likelihood. And then we do the rest of the config just like we did before. So number of in be 10, number of out will be the number of classes, so that'll be 3, and then our activation function will be softmax because they're doing clustering. So that should be all we need. Oh, and just for demonstration purposes, we're going to set backpropagation to true. Cool. Now, this is good, but it's just Clojure data. So we need to turn this into a network. So we're going to call irisnet AI network, and we just plug in that. And we can see that this works by running boot night like this. So we have a multi-layer network object from Deep Learning 4J. Cool. Let me just look at my example again. Oh, I need to update that. So then we're going to call our initialize net, which does some fancy stuff for us. But at the end of the day, we can do that with this arrow function, which you can look up, but it basically just passes this as the first argument to this. So initialize net, and let me make sure I did that right. Yep, good to go. So actually, that's normally what it looks like. So let me look at this real quick again. Alrighty, so now we're ready to train our neural net. And we'll do this. We'll make a function called trainNet, and we don't have any arguments to this. And we're gonna take our network object, and then we're gonna call the train method or function, which is, it's gonna change that object so it has this bang at the end. So And the first argument to this will be this iris net, which we don't have to include because we're using this arrow function. Then we're going to tell it how many iterations, and we're going to give it the iterator. And because we want to, not have to recreate our work, we're also going to save the model, and we're going to call it iris net. So we can use that later if we wanted to. The next thing we want to do is we're going to reset the iterator because it's already ran through, and we're going to use that data to evaluate the performance of our neural net after training. We do this, and we do the iris iterator, and we're going to print that out. And then we can just call this function. And it should all work. So just do boot run. And we can see that the performance was okay. There we go. So the learning rate wasn't right. That was my bad. But that does show you how that kind of all works, if you did want to customly set it. So the default setting, as you can see, worked much better, and we're having a pretty decent accuracy. This data set's really small, so you're not going to get very great results, so it's just for demonstration purposes. So the next thing we could do is, this is a cool way to visualize our data, but I actually have another project called jutsu.ai.ui, and we can include that. Let's look at which is 001. So we'll go back to our here, and then so this will let us visualize the training, which is cool. We can do this by ui.core as UI, and then we change this to initialize with UI. That's all we have to do, and we won't need this anymore, so we can delete that. And then what the initialize with UI is going to set up a server which we can access the web page with our browser. So we're going to need to call the wait task so it doesn't just exit our program, because this will train really fast. And we'll see it. So it does a bunch of stuff. Don't worry, it's not erroring. And we see that our server started at HTTP localhost 9000. So we can access that. And it gives us kind of this visualization of the training. And we can see it sort of converges over time after, it's doing 200 iterations. Which this UI is pretty sweet that deep learning made. And you can also see the visuals of the layers. And that's how to use jutsu.ai. I hope you learned how to do some machine learning in Clojure.